Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome back to Wednesday Night Math Night. I am so excited to be back with you. I love Wednesday Night Math Night. It is truly something that I love doing. Hi, Beth. You've missed for the past few weeks. That is okay. I am glad to see you back. Hi, C. You're taking the GK math test in 2 weeks. This is going to be helpful for you then. Trust me. Hey, John. It is good to see you. So don't mind me. I just realized my computer is about to die, and if it dies, that's not good, and I don't have my charger. So I'm going to text my husband and tell him, please bring me the computer charger. I hope that you all have, oh no, Lordy, my computer charger is right here in my bag. I am a mess right now. I hope you all had a great Halloween. It was my baby's, it was really his first Halloween. It was his second Halloween, but we didn't really do much last year because he was only like 7 months old. So this year he was dressed up as Clark Kent, and his best little friend, our best friends, their kid was dressed up as Superman. So it was super cute, the two of them running around the neighborhood. And now, as you can see, it's Christmas in our house. I purposely wore this shirt because I told you guys last week Christmas would be up in my house today. It is not, because I came home from work and had to prep for this, but Christmas is going up this week. So yeah. So with that said, I always like to do a get to know you question before we get started with our math problems. So let in the comment box where you're from, what test are you prepping for, and if you could pick one Christmas movie, would it be Elf or Home Alone or neither? Like, you don't like Christmas movies, you don't celebrate the holidays, and you would pick Cinderella Story instead. So if you're not a holiday person, that is okay. What is your favorite movie? Otherwise, would you pick, if you do celebrate the holidays and you celebrate Christmas, would you pick Elf or Home Alone? I am an Elf girl all day long. Hey, Melissa, it's good to see you. You've got this. I'm an elf girl all day long, or the Grinch, the new one, not the old one. So Elf or the Grinch. I'm not a Home Alone person. My husband loves Home Alone, so we have to watch it at least 15 times a season, and we have to watch Elf at least 15 times a season. And it's not even Thanksgiving yet, and I promise I won't talk about Christmas every week until Christmas, just this week because it's fun, because it's the day after Halloween. So with that said, hey, Chris, Home Alone, love it. Hey, Melissa, EC6, awesome. The Santa Claus, I love the Santa Claus movies. Gosh, it's so hard to pick. I still love Elf, but the Santa Claus is a close second. The Griswold, I have to say I've never watched that movie. Maybe I need to watch it this year. So let's go ahead and now that we've talked about all the fun Christmas movies and holiday movies and all the things. Oh, have y'all watched what's the new one? Noelle on Disney Plus. If you have not watched that one, it's super cheesy, but it is so good. Let me know in the comments if you've watched that one. I watched that one, I think, last year for the first time, maybe 2 years ago, and I died. I am a Christmas movie girl all the way, and I was obsessed. So if you haven't watched that one, you have to check that one out. Okay, a little housekeeping before we get started. I always have like a next week slide prepared. So this is going to be my next week list. If there is anything that you want me to go over in the next couple weeks, you let me know in the comment box as we're working problems out, and I am happy to add it to my next week list or the next couple weeks. This is the best way to tailor, this is the best way to tailor content for you. I see a couple of people are taking their tests like in the next couple of weeks. So if you are struggling with something specific, let me know in the comment box. So I will kind of have this as a running list. I love that you love it, Melissa. The other one that I recently watched, which apparently is old, are what are those little like short movies? They're like 20 minutes and they're like elves and like what they do when they prepare the house for Santa Claus. I don't remember what it's called, but they're like 10 or 20 minutes and they are adorable and they're on Disney Plus. Word problems. You've got it. You will actually find some word problems tonight. Anything specific in those word problems? Let me know. Prep and Landing. Y'all are my people. Yes, Beth. Prep and Landing. You've got to watch Prep and Landing. All right. It's been 9 minutes. We got to get going. All right. First problem. Why is it not swiping? All right. We're just going to have to do it this way. A basketball court. Here is a word problem. Fundamental counting principle. Finite number of outcomes in probability. All right. Fundamental counting. You're gonna make me Google that, aren't you? I'm gonna have to go pull out a math book to figure that one out. Principal ratio, percents and decimals. Absolutely. Y'all are coming up with some good stuff this week. And finite number of outcomes in probability. All right. Keep it coming. All right. Word problem. A basketball court is being repainted. The entire court has been repainted except for each of the 2 keys with dimensions shown below. If paint costs $1.50 per square foot, what will it cost to paint the keys? All right. Listen, this problem would probably take me about 4 minutes. So that said, what I'm about to explain is probably going to take 10 minutes, realistically, because I want to go through, there's a lot of pieces to this puzzle. And there's a lot of pieces to this puzzle that are going to benefit everybody. But what I need you to understand is what I'm about to explain, I would not normally go through all of this explanation when I'm taking the test. This problem would probably take me about 4 minutes. So if I'm trying to figure out the cost to paint the keys, and the paint costs $1.50 per square foot, that word square indicates that I'm looking for what? Area. So in order to figure out this problem, I have to find the area of the key in square feet. And then I have to multiply the area times 150 because it's 150 per square foot. So if I'm trying to find how much it's going to cost, I'm going to multiply the area times that per square foot. How am I going to find the area of the key, though? How am I going to find the area of the key? There's no special area formula for this wonky, rounded off shape. So what I need to do is I need to slice it into a rectangle and a half circle. And quite frankly, usually in the problem, it's going to say something to the effect of like, you know, each of the two keys, which includes a half circle or something like that. So I'm going to chop it into a half circle and a rectangle. So I know the area of a rectangle is length times width. And for those of you who are taking a test that has a reference sheet, that's on your reference sheet. Melissa, what's not fun? This math, this problem is so fun. Now, I know that my length, and I don't know where my line just went. I know my length is 19 and my width is 16, or vice versa. Multiplication is commutative, which means I can do it in any order. So I can do 19 times 16, or I can do 16 times 19. If I have a handy dandy calculator, I'm going to use it. So 19 times 16 equals 304 feet squared, which is the area of the rectangle. And actually, I don't need to write that because when I'm taking a test, I will often do what you see here, area of the rectangle equals. That way I know what I'm working with and I'm not losing myself in my work. Melissa, amen. You are correct. That is not fun, but I will do it just for you. All right, then I need to find the area of my half circle. What is the area of a circle? Pi r squared. Pi r squared. So I know, and I'm going to drag this down here a little bit. Area of a circle equals 3.14. And again, normally they would say like pi, use 3.14 for pi. If they don't say that, then 3.14 is used for pi. Times, what is my radius? Now, here's where I'm going to divert from the problem for a minute for my EC6, elementary people, just for some conversation about a circle. Here's my circle. My circle has a center, it has a radius, and it has a diameter. A radius extends from the middle to the outside. A diameter goes from one end of the circle to the other through the center. So I have area equals pi r squared. I need my radius. Well, if I establish a center right here, I need this value right here. What is that value? Well, we know that this is also R, and R plus R has to equal 16, because if this side is 16, then this side has to be 16 as well. R plus R equals 16. 16 divided by 2 equals 8, so 1R equals 8. So pi R squared, area equals, I'm going to pull out my handy dandy calculator. I know that 8 squared is 64, so now I just need to use my calculator to do 3.14 times 64, which is 200, whoopsie daisy, 0.96. Now what do I need to do? I have the area of my rectangle. I have the area of my circle. This is going to be the number one error, and I almost just made it. What is this the area of? The whole circle. I only have a half of a circle. So I need to divide this by 2, which equals 148 hundredths. I almost just made that error. Now I can add the 304 and the 100.48. And that's going to give me, not 104, 100.48, which is going to equal 404.48. That is the area of the key. Now what am I going to do? Now I'm going to add that or multiply that times 150. And that's going to give me, there's not going to be a correct answer, and I'll tell you why in a minute. $606.72. Actually, there is going to be a correct answer. There is. I just realized. I'm about to make so many errors. So $606.72. Now, had you used this number and this number, you would have gotten $757.44. But what did I miss over here? There are 2 keys. And they asked us, what does it cost to paint the keys? Not a key. Part of taking these math tests is not just doing math. It's interpreting the words that are being presented to us. So I need to multiply my answer, 606.72, by 2, or I need to do 606.72 plus 606.72 because there are 2 keys, which means the answer is $1,213.44, which is B. This was a multi-step problem. And this is where they catch us, because there are many places where we can make small errors that are going to cost us the problem. The key is what the basketball, that shape is called. That's a really good question. So this shape that they shoot free throws in is the key right here. That was a good question, Chris. All right, let's go on to problem number 2. Simplify. 8 times 5 minus 3, parentheses 3 squared times 4, parentheses divided by 1/2 plus 9. All righty, so we are simplifying this expression. When we simplify an expression, we have to remember PEMDAS. Please excuse my dear Aunt Sally, where P is parentheses, E is exponents, M is multiply, D is divide, A is add, and S is subtract. Why did I cluster the parentheses, the exponents, the multiplication, the division, the additions, the subtraction? Why did I cluster those together? Because they are kind of like married. So I clustered them together because in that situation, I'm going to do what comes first from left to right. I always love like those Facebook wars where it's like, what is the answer to 3 divided by 3 times 3? And I think that's one of the examples. Yes. What is the answer? Let's just stay here for a minute. This is one that I see on Facebook all the time. And there are 2 answers that people argue about. Some people say that the answer is 3, and some people say that the answer 1/3. What's the correct answer? Well, if we do PEMDAS in the order that it is shown, then that means that I would do 3 times 3 first because it's multiplication. So 3 divided by 9, and 3 divided by 9 is 1/3. But that is incorrect. When we are looking at order of operations, when we get to multiplication and division, we go from left to right if there's nothing else in the problem. So in this situation, I am going to do 3 divided by 3 first, which is 1. And 1 times 3 is 3, which means A is the correct answer. Now, that is a very simple version of order of operations and how one small change can drastically change the entire course of the problem. So let's go ahead and look at this one. I am going to look for parentheses and exponents first. So I see exponents inside my parentheses. So I am going to do that first, and I'm going to copy everything else down. I'm not going to try to do steps in my head. So I'm going to say 8 times 5 minus 3 times 3 squared is 9 times 4 parentheses divided by 1/2 plus 9. Now I'm going to do the parentheses part. I'm going to keep everything else the same. So 8 times 5 minus 3 times 36, because 9 times 4 is 36, divided by 1/2 plus 9. Now I am done. Parentheses and exponents is complete. So that said, now I need to solve multiplication and division. Now, some of you might be saying, hey, Amy, multiplication or parentheses and exponents is not done. You still have a set of parentheses right here. You are absolutely correct. I do. But those parentheses at this point are just serving as a representation for multiplication. So I have 8 times 5 minus 3 times 36 divided by 1/2 plus 9. So now I'm going to solve this piece of multiplication. I'm going to keep everything else the same. So I already solved this and I got 36. But now I'm going to solve this and I'm going to get 40. I'm now going to solve -3 times 36 and then keep everything else the same. So now I'm solving this part. What is -3 times 36? I don't know. Use my handy dandy calculator. 108. So 40 minus 108 divided by 1/2 plus 9. And if you're new with us, sometimes my iPad likes to just disconnect for some reason. Got about halfway through today without it happening. That's impressive. And let's see. There we go. I have to mirror it to my computer, so it takes a minute. Do dee do dee do dee do do dee do dee do 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 dee do dee. All right. All right. Now I am going to solve the division part of it. Now in this particular problem, the multiplication happened to come before the division. But if it was the opposite way around, I would do the division first and then the multiplication, even if the division came first. So now I'm going to do 108 divided by 1/2. Please keep in mind 108 divided by 1/2 is not the same as 108 times 1/2. I'm going to say that again. Keep in mind that 108 divided by 1/2 is not the same as 108 times 1/2, nor is it the same as 108 divided by 2. That is going to be one of the most common mistakes that is made right now, is that people are going to do 108 divided by 2 rather than 108 divided by 1/2. Let's consider what this means, and this piece is for everybody. 108 negative divided by 1/2. What does that mean? That means I'm doing fraction division, which means I can't. Well, you can, but the way you do it is by keep, change, flip. Keep the first one, multiply, flip the second one. There's a whole long explanation as to why. And if you want to know, let me know and I'll take some time to explain that. But it is not for this problem. So -108, I'm keeping. Change the sign to multiplication. Flip the fraction. So it becomes 2/1 instead of 1/2. And 108 times 2 is -216. So this becomes 408 minus 216 plus 9. Now I can solve moving from left to right, because now I have officially made it to the addition and the subtraction clump. So I'm going to do 40 minus 216. And I'm going to get -176 plus 9. which equals negative 167, which is my answer. Now, you're asking, why did you do the subtraction instead of the addition first? Because once I get to a point where I only have multiplication and division, or I only have addition and subtraction, I'm moving from left to right. Even if there's addition and subtraction, if there's multiplication, division, addition, and subtraction, but I'm operating under the multiplication and division like bracket, I'm going to move from left to right within the multiplication and division. So because subtraction and addition are kind of on the same playing field, I'm going to move from left to right rather than doing that addition first. So A is the right answer. Don't forget, if you have questions, don't hesitate to ask me. And if you want to see something next week, let me know and I will add it to the next week slide. Let's go ahead and move to the next problem. A gym offers 2 monthly plans. Plan A costs $10 per month after an initial $99 fee. Plan B costs $22 per minute of calls after an initial $15 fee. What is the cost of the 2 plans in dollars when they are the same price? So we have 2 monthly plans being offered. We have A costs $10 per month after a $99 fee. And that's a one-time fee. It's an initial fee. It's out the gate and then you never pay it again. Plan B costs $22 per minute That's a lot of dollars per minute after an initial $15 one-time fee. What is the cost when they are the same? So this right here screams system of equations. Or it screams linear equations, really is more what it is. And when I have a system of equations or linear equations, and I'm trying to find when they are the same price, I want you to think about when we graph linear equations on a line, and let's say this is plan A, and let's say this is plan B. Where they intersect is going to be the only place that they are the same price. It's going to be the only place that they are the same price. So when we consider plan A, I'm going to set up my linear equation. I'm paying $10 per month, 10 times the first month, 10 times the second month, 10 times the third month, 10 times the fourth month, 10 times the fifth month, plus a $99 fee. Plan B is $22 a minute, so 22 times X, plus $15. So no matter if I talk on the phone for 0 minutes or 932 minutes, I'm still paying that $15 fee. So how do I figure out when they are the same? Well, what happens when things are the same? What do we call that in mathematics? We call that equal. So if I set this equal to this, I can figure out where they are the same. So let's go ahead and do that. 10x plus 99 equals 22x plus 15. Now all I need to do is get my x's together, get my non-x's together, and then solve for x. So I'm going to subtract 10x from both sides. Why am I not doing 10x plus 99 equals 109? Because they're not like terms. I can only add things that are like terms, which means I can only add x's with x's and non-x's with like constants with constants. So I'm left with 99 equals 12x plus 15. Now, could you have subtracted 22x from both sides? Yeah, absolutely. You would get the same answer. Now I'm going to subtract 15. And I get,
I found this on the web.
oh, thank you, Siri. I get 12x equals, I'm going to do 99 minus 15 in my calculator, 84. Now what do I do to get x by itself? Divide both sides by 12. You're absolutely right. So divide by 12, divide by 12, x equals 7. But is that the cost, or is that the number of months, the number of minutes, all of that? X represents the per. $10 per month, $22 per minute. So now I need to plug the 7 back into either one. It does not matter because it's where they are the same. So if I plug 7 into this equation right here, I'm going to get the exact same answer as if I plug 7 into this equation right here. I'm going to plug it into the 10 just because I know that 10 times 7 is really easy. So I'm going to do 10 times 7 plus 99. 10 times 7 is 70. 70 plus 99 is 169. So D is the correct answer. But I'm telling you, if you plugged it into this equation right here, you would have gotten the same answer. 22 times 7 plus 15. 22 times 7 is 154 plus 15 equals 169. Doesn't matter, same answer. All right, let's move on to problem number 4. This is one we did last week, and we're going to, not this exact problem, I just changed the numbers, but we're going to do it again this week too. Which of the following geometric solids has 8 faces, 12 vertices, and 18 edges? Which of the following geometric solids has 8 faces, 12 vertices, and 18 edges? So last week, we went over the difference between a prism and a pyramid. Everybody needs to understand the difference between a prism and a pyramid. So, quick recap. A prism has 2 identical bases and rectangles surrounding. A pyramid has 1 identical base with triangles extending, there goes my iPad, up. Let's reconnect. No, don't want to, there we go. It keeps trying to connect to my living room, which I don't understand. It's reconnecting. Did we have this many issues last week? I feel like last week was a really good week. Those of you who were here last week, did we have this many issues last week? I don't think we did. I think we had a really good week last week. All right, here we go. So, a prism, I want you to hear me out. Mathematicians are not creative when they name things. So, when they name it a triangular prism, guess what shape the bases are? A triangle. When they name it a pentagonal prism, guess what shape the bases are? Pentagons. When they name it a rectangular pyramid, guess what shape the bases are? Rectangles. So when we go to draw this, if I draw a triangular prism, I'm going to draw two identical triangle bases and then rectangles surrounding it. Now, the number one error that people make when interpreting a prism is they assume that this is the base because often this is how prisms are drawn, sitting on that bottom piece. But that is not the base. The base are the two identical shapes that are securing those rectangles going around it. So how many faces does the triangular prism have? Well, it has the two bases. So a face is like the flat surface. So it has 1, 2, but then how many rectangles does it have going around? It has 1 for this side. Here it is. It has 1 for this side. Here it is. And it has 1 for this side on the bottom. So the number of rectangles equals the number of sides your base has. So this has 2 bases plus 3 rectangles because a triangle has 3 sides. So this has 5 faces. A triangular prism is out because we're looking for 8. So without drawing it, how many faces does this guy have? It has 2 bases plus how many rectangles? 5, because a pentagon has 5 sides. That equals 7 faces, so that one is out. Now, a pyramid has 1 base, plus the number of sides that the base has is the number of triangles going around to pull it to the top. So if I were to draw a hexagonal pyramid, a hexagon has 1, 2, 3, 4, 5, 6 sides. And then there's going to be triangles that extend up for every side that we have. So you have this front triangle for this side. This side has its own triangle. This side has its own triangle, as does every other side. So a hexagonal prism is going to have 6 triangles. And a rectangle pyramid is going to have 4 triangles. So look at that. None of them are correct. So what, let me throw this out to you. Let me throw a critical thinking question out to you. What would have 8 faces? A hexagonal prism. 2 bases plus 6 rectangles is going to equal 8 faces. It also will have 12 vertices because the number of vertices in a prism is just double the number of sides that your base has, because the vertices are your bases. So vertice, 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 vertice. A triangle has 3 sides, so this is going to have 6 vertices. A hexagon has 6 sides, so this is going to have 12 vertices. So the answer to this problem is a hexagonal prism. All right, let's go ahead, and I think we have time for like 2 more. Which of these is the slope-intercept form of the line that passes through points -4, -6, and has an x-intercept of 2? Which of these is the slope-intercept form of the line that passes through this point and has the x-intercept of 2? Well, I can automatically cross out 2 of these answers. Which 2 can I cross off? A and C. Why? Because A and C are point slope form. Point slope form. Slope intercept form is y equals mx plus b. Now, can I put it in point Can I put it in point slope form and then transition it into slope intercept form? Absolutely. But the answer needs to be in slope intercept form because that's what they asked for. So now we need to figure out what the slope and the y-intercept are to be able to solve our problem. Now, slope formula is y minus y over x minus x, or rise over run. There goes my iPad again. 3rd time's the charm, y'all. 3rd time's the charm. Just going to nail it right now. Say 3rd time's the charm, and it's not going to disconnect anymore. It's connecting, connecting. There we go. Okay. And then every time it reconnects, I have to retell the streaming platform to share the screen. All right, so slope is y minus y over x minus x, or rise over run. If the x-intercept is another point that we have, what is the coordinates of that point? 2, 0. Because it's the x-intercept, which means it's where the line crosses the x-axis, which means I'm going over some, but I'm not going up or down any. So I can take this point and find my slope. But is that necessary in our problem? No. I don't need to do all of this work. Why? Because they both have the same slope, which is 1. So I don't need to do all that work. Now, I'm going to do it right now so that you understand how to solve the slope formula. So let's go ahead and plug in my y's. My y's are -6 and 0. So I'm going to do -6 minus 0 divided by -4 minus 2 -6 divided by -6 equals +1. The number one error people make is either they do the x's on the top or they do -6 minus -4 and they do an x and a y rather than y minus y, x minus x. So my slope is 1. What is my y-intercept? Don't know. This is my x-intercept. This is my y-intercept. I don't know if it's +2 or -2. So now I'm going to plug it into point slope form, which is y minus y1 equals m times x minus x1. I'm going to plug my slope in for my slope, and I'm going to plug my point in for my point. Y minus -6 equals 1 times x minus -4. Distribute the 1, which is just nothing. Like 1 times anything is itself. So I have y plus 6 equals x plus 4. Subtract 6 from both sides, and I get y equals x minus 2, which is B. There goes my iPad again. I'm telling you, I feel like this thing is like trying to tell us we're going to be all for the night. So, what else do you want to see me go over in the upcoming weeks? What else do you want to see me go over in the upcoming weeks? And we'll see if we can get through one more problem without this thing like disconnecting again. But what else do you want to see from me in the next couple of weeks? And I'm going to pick, yeah, I guess this is a good one. All right. A triangle is inscribed inside a square. What is the area of the shaded region? So what we need to do is find the area of this square and then subtract out this triangle. I have done a problem similar to this, so I'm going to show you a different way to do it tonight. I know that this square has sides of 12 and 12 and 12 and 12, which means that this is 6 and this is 6. So area of my square equals 12 times 12, which is 144. I know D is not the right answer because that's the area of the whole square, not the area of the shaded parts. Watch what's going to happen when I do this. If I cut my square in half, this is going to be 6 because this is 6. And what is that going to be? 12. These triangles are exactly the same as these triangles. So rather than finding the area of each triangle, adding them together, subtracting it out, the shaded area is just half the square because this triangle is the same as this triangle. So 2 triangles are shaded, 2 are not. So I can divide 144 by 2. My answer is 72. Now, could I find the area of a triangle? 1/2 base times height, 1/2 times 6 times 12. 72 divided by 2 is 36. And then that's this triangle. And then do this triangle also. And 36 plus 36 equals 72. Absolutely, I could do that. But I just wanted to show you a different way to think about the problem, because sometimes we just need that. So I'm going to hang around while I turn it over to Dr. A. I'm going to turn it back over to him. He has a special code for you guys. And I will see you all next week. I promise I won't be wearing a Christmas shirt next week. I'll start wearing Christmas shirts after Thanksgiving, but I just had to today. And I will see y'all next week. Let me know in the comments what you want to see me go over in the upcoming weeks, and I will see you all next week. Back to you, Dr. A.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.